Okay, welcome to chapter 1, Introductions to Data Communications and Networking. So this slide is referred to textbooks Behrus Ferozan, okay, 4th editions. Introductions to Data Communications and Networking. At the end of the lesson, okay, students should be able to differentiate each data flow, the physical structure of the networks, and then can differentiate the physical topologies and categories of networks. And then students should be able to draw different types of data flow and the physical topologies of networks. Okay, so this is the today's subtopic. Okay, firstly, data communications, the fundamental characteristic, the components, the data presentations, and the data flow. Okay, secondly, the network subtopic, okay, network criteria, the physical structures, network models and category of networks, and then we look at the internet. Afterward is the protocol and standards, and then you can do some exercises for your better understanding. Data communications and networking are changing the way we do business and the way we live. Business decisions have to be made ever more quickly, and the decision makers require immediate access to the accurate information. Why wait a week for that report from Germany to arrive by mail when it could appear almost instantaneously through the computer networks? Businesses today rely on computer networks and internet networks. But before we ask how quickly we can get hooked up, we need to know how networks operate, what type of technologies are available, and which design best fill which set of need. When we communicate, we are sharing information. This sharing can be local or remote. Between individuals, local communication usually occurs face-to-face, while remote communication takes place over the distance. The term telecommunication is actually derived from the word tele, means far in Greek. So combine those words means communications at a distance, which includes telephony, telegraphy, and televisions. The word data refers to information presented in whatever form is agreed upon by the parties creating and using the data. Therefore, data communications are the exchange of data between two devices via some form of transmission medium such as wire, cable, or wirelessly. For data communication to occur, the communicating devices must be part of communication system made of a combination of hardware, which is physical equipment, and software, which is the program. The effectiveness of a data communication system depends on 4 fundamental characteristics: delivery, accuracy, timeliness, and jitter. Let me explain them for you. Firstly, delivery. The system must deliver data to the correct destination. Data must be received by the intended device or user, and only by that device or user. For example, if we send a letter to our parents but our parents did not receive the letter, then the delivery is not successful, which means the communication is not effective. Secondly, accuracy. The system must deliver the data accurately. Data that have been altered in the transmission and left uncorrected is unusable. For example, if I send to you this video but the video is corrupted due to problem when you download it, which means you didn't get the message that I tried to deliver through the video, means the communication is not effective. Next, timeliness. The system must deliver data in timely manner. Data delivered late are useless. In the case of video and audio, timely delivered means delivering data as they are produced in the same order that they are produced and without significant delay. This kind of delivery is called real-time transmission. Lastly, jitter. Jitter refers to the variations in the packet arrival time. It is the uneven delay in the delivery of audio or video packets. For example, let us assume that video packets are sent every 30 milliseconds. If some of the packets arrive with a 30 millisecond delay and the other with 40 millisecond delay, an uneven quality of the video is the result. If we are having video call through our mobile phones or laptop, for example, jitter in voice over internet protocol communication can be severely impact the call quality, even causing conversations to drop out and become jumbled and difficult to understand. Next, we have component of data communications. A data communication system has 5 components. Firstly, message. The message is the information data to be communicated. Popular form of information include text, numbers, pictures, audio, and videos. Secondly, we have is sender. The sender is the device that sends the data message. It can be a computer, workstation, telephones, handsets, video camera, and so on. Thirdly, we have receiver. The receiver is the device that receives the message. It can be a computer workstation, telephone handset, televisions, and so on. Next is transmission medium. The transmission medium is the physical path by which a message travels from sender to receiver. For some examples of transmission medium includes twisted pair cable, coaxial cable, fiber optic cable, and radio waves. We will touch more on this in chapter 6. And lastly, we have protocol. A protocol is a set of rules that govern data communications. It represents an agreement between the communicating devices. Without a protocol, two devices may be connected but not communicating, just as a person speaking French cannot be understood by a person who speaks only Japanese. Data representations. Information today comes in different forms such as text, numbers, images, audio, and video. In data communication, text is represented as a bit pattern, a sequence of bits which is zeros or ones. Different set of bits pattern have been designed to represent text symbols. Each set is called a code, and the process of representing symbol is called coding. Numbers are also represented by bit patterns. However, a code such as ASCII is not used to represent numbers. The number is directly converted to a binary number to simplify mathematical operations. Next, images. Images are also represented by bit patterns. In its simplest form, an image is composed of a matrix of pixels, or we call as picture elements, where each pixel is a small dot. The size of the pixel depends on the resolution. For example, an image can be divided into 1,000 pixels or 10,000 pixels. In the second case, there is a better representation of the image, but more memory is needed to store the image. After an image is divided into pixels, each pixel is assigned a bit pattern. The size and the value of the pattern depend on the image. For an image made of only black and white dots, for example a chessboard, a 1-bit pattern is enough to represent a pixel. If an image is not made of pure white and pure black pixel, you can increase the size of the bit pattern to include grayscale. For example, to show 4 levels of grayscale, you can use 2-bit patterns. A black pixel can be represented by bit 00, a dark gray pixel by 01, a light gray pixel by 10 and 10, and a white pixel by 11. There are several methods to represent color images. One method is called RGB, so called because each color is made of a combination of 3 primary colors, red, green, and blue. The intensity of each color is measured and a bit pattern is assigned to it. Another method is called CMY, in which a color is made of combination of 3 other primary colors, cyan, magenta, and yellow. Next we have is audio. Audio refers to the recording or broadcasting of sound or music. Audio is by nature different from text, numbers, or images. It is continuous, not discrete. Even when we are using microphone to change voice or music to an electrical signal, we create a continuous signal. Lastly, video. Video refers to the recording or broadcasting of a picture or movie. Video can either be produced as a continuous entity, for example by a TV camera, or it can be a combination of images, each a discrete entity arranged to convey the idea of motions. Communication between two devices can be simplex, half-duplex, or full-duplex. In simplex mode, the communication is unidirectional as on a one-way street. Only one of the two devices on a link can transmit, the other can only receive. Keyboards and traditional monitors are examples of simplex devices. The keyboard can only introduce input, and the monitor can only accept output. The simplex mode can use the entire capacity of the channel to send data in one direction. In half-duplex mode, each station can both transmit and receive, but not at the same time. For example, when one device is sending, the other can only receive, and vice versa. The half-duplex mode is like a one-lane route with traffic allowed in both directions. When cars are traveling in one direction, cars going to the other way must wait. In a half-duplex mode transmission, the entire capacity of the channel is taken over by whichever of the two devices is transmitting at the time. Walkie-talkies and citizen bands radios are both half-duplex systems. The half-duplex mode is used in cases where there is no need for communication in both directions at the same time, which means the entire capacity of the channel can be utilized for each direction. Next, full duplex. In full duplex, which also called duplex, both stations can transmit and receive simultaneously. The full duplex mode is like a two-way street with traffic flowing in both directions at the same time. In half-duplex mode, signals going in one direction share the capacity of the link, with signals going in the other directions. This sharing can occur in two ways. Either the link must contain two physically separate transmission paths, one for sending and the other for receiving, or the capacity of the channel is divided between signals traveling in both directions. One common example of full duplex communication is the telephone networks. When two people are communicating by a telephone line, both can talk and listen at the same time. The full duplex mode is used when communication in both directions is required all the time. The capacity of the channel, however, must be divided between the two directions. Now we will look into networks. What is networks? A network is a set of devices which often referred to as nodes, connected by communication links. A node can be a computer, printer, or any other device capable of sending and or receiving data generated by other nodes on the network. Most networks use distributed processing, in which a task is divided among multiple computers. Instead of one single large machine being responsible for all aspects of a process, separate computers, usually a personal computer or workstation, can handle a subset. A network must be able to meet a certain number of criteria. The most important of these are performance, reliability, and security. Okay, let's look at the first one, performance. Performance can be measured in many ways, including transit time and response time. Transit time is the amount of time required for a message to travel from one device to another. And response time is the elapsed time between an inquiry and a response. The performance of a network depends on a number of factors, including the number of users, the type of transmission medium, the capabilities of the connected hardware, and the efficiency of the software. For example, the highway. There are certain times of a year that our highway become congested as most road users are on the road to travel around the country. For example, on the festive seasons or school holidays. Therefore, the road users become increases and make the highway jam with vehicles. It will make the traffic move slow and sometimes not moving at all. Stagnant. It's also the same for your network. If there are too many users, the data traffic will become slow and sometimes it seems like not moving at all. Type of transmission medium also play part in the network performance. There are differences between using wired and wireless connection, and also there are differences when we are using 3G or 4G connections. It's all because of the material that we use in the wired or the technology we use in the wireless. Next, capabilities of connected hardware. Okay, let's look at our devices. Do you use USB ports? Does your USB connection is 3.0 or still using 2.0 connections? If the port is USB 2.0 or 2.5, it is useless for you to use flash drive with USB 3.0 as it's not working that is supposed to do, as it cannot transmit data faster as the connected device cannot process the data faster. It is the same with our network. Okay, it depends on the capability of the connected hardware. Next, with an efficient software, it enables the network to be intelligently and centrally controlled or programmed using software applications. This helps operators manage the entire network consistently and holistically, regardless of the underlying network technology. Performance is often evaluated by two networking metrics, throughput and delay. We often need more throughput and less delay. However, these two criteria are often contradictory. If we try to send more data to the network, we may increase throughput, but we increase the delay because of the traffic congestions in the network. Okay, sorry. because of the traffic congestions in the network. Okay, next we have is reliability. In addition to accuracy of delivery, network reliability is measured by the frequency of failure, the time it takes a link to recover from a failure, and the next robustness in a catastrophe. And lastly, security. Network security issues include protecting data from unauthorized access, protecting data from damage and development, and implementing policies and procedures for recovery from breaches and data losses. Data losses. Okay, whatever it is, data lost. Okay. When we are talking about the network, we are talking about the physical structures of the network. Okay, before we going further, we need to define some of the network attributes. Firstly, if we're talking about the type of connections. A network is a two or more devices connected through the links. Okay, a link is a communication pathway that transfers data from one device to another. For visualization purposes, it is simplest to imagine any links as a line drawn between two points. For communication to occur, two devices must be connected in some way to the same link at the same time. There are two possible types of connections. One is point-to-point, and secondly is multi-point. Okay, what is point-to-point? Point-to-point is a connection which provides a dedicated link between two devices. The entire capacity of the links is reserved for transmission between the two devices, and most point-to-point connections use an actual length of wire or cable to connect the two ends, but other options such as microwave or satellite links are also possible. When you change television channel by infrared remote control, you are establishing a point-to-point connection between the remote control and the television control system. Okay, next is a multi-point. A multi-point, or also called as a multi-drop connection, is one in which more than two specific devices share a single link. In a multi-point environment, the capacity of the channel is shared either partially or temporarily. If several devices can use the link simultaneously, it is partially shared connections. If user must take turns, it is time-shared connection. Okay, next we have is the physical topology. There are several types of physical topologies that a network can have. Okay, so we look one by one. Firstly, we have is mesh topology. In a mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries traffic only between the two devices it connects. To find the number of physical links in fully connected mesh network with n nodes, we first consider that each node must be connected to every other node. The formula to calculate how many cables that we need in mesh topology is n times n minus 1 divided by 2. And formula to calculate how many ports a device needs to connect to other device is n minus 1. Secondly, star topology. In a star topology, each device has a dedicated point-to-point link only to a central controller, usually called a hub. The devices are not directly linked to one another. Unlike a mesh topology, a star topology does not allow direct traffic between the devices. The controller acts as an exchange. If one device wants to send data to another, it sends the data to the controller, which then relies the data to the other connected device. Next we have is bus topology. The preceding example all describe point-to-point connections. A bus topology, on the other hand, is multi-point. One long cable acts as a backbone to link all the devices in a network. Nodes are connected to the bus cable by drop lines and tab. A drop line is a connection running between the device and the main cable. A tab is a connector that either splices into the main cable or punctures the sheeting of a cable to create a contact with the metallic core. As a signal travels along the backbone, some of its energy is transformed into heat. Therefore, it becomes weaker and weaker as it travels farther and farther. For this reason, there is a limit on the number of tabs a bus can support and on the distance between those tabs. Now we have ring topology. In a ring topology, each device has a dedicated point-to-point connection with only the two devices on either side of it. A signal is passed along the ring in one direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. When a device receives a signal intended for another device, its repeater regenerates the bits and passes them along. And lastly, we have hybrid topology. A network can be hybrid. Okay, for example, we can have a main star topology with each branch connecting to several stations in a bus topology or rings. Okay, so each of the topology that we have discussed before have their own advantages and disadvantages. In the next slide, we will look at some of it to be discussed with. Okay, this is some of the comparison that we can do between those topologies. Okay. Okay, now we have network models, but we will skip this for now as we will be discussing this in chapter 2. Okay. Okay, next we have is categories of networks. Okay, today when we speak of network, we are generally referring to two primary categories: local area networks and wide area networks. The category into which a network falls in is determined by its size. A LAN normally covers an area less than 2 miles. A WAN can be worldwide. Okay, so networks of a size in between are normally referred to as metropolitan area networks and span tens of miles. But actually, we have two other categories of networks. Okay, we have PAN, personal area networks, and also CHAN, central area network, or campus area network. Therefore, let's look at each of them. Okay, so firstly, we have PAN. A personal area network is a computer network for interconnecting electronic devices centered on an individual person's workspace. So a PAN provides data transmission among devices such as computers, smartphones, tablets, personal digital assistants. For example, if I connect my laptop to a printer, so it's actually a PAN. Okay, and then we have LAN. A local area network is a computer network that interconnects computers within a limited area such as residence, school, laboratory, like in our campus, okay, or office building. Next one is CHAN. A campus area network or central area network is a network of multiple interconnected local area networks in a limited geographical area. So a CHAN is smaller than a wide area network or metropolitan area network. Okay, so a CHAN is also known as a corporate area network, means that it's a smaller than metropolitan, means that it covers only a limited geographical area. Okay, next we have MAN. A metropolitan area network is a network that interconnects users with computer resources in a geographic area or region larger than that covered by even a large local area network, or means a CHAN, but smaller than the area covered by the wide area network. Okay, next we have is WAN. It is simplest form. A wide area network is a collection of local area networks or other networks that communicate with one another. A WAN is essentially a network of networks, with the internet is the world's largest WAN. Today, there are several types of WANs built for a variety of use cases that touch virtually every aspect of modern life. Can you imagine your life without the internet? Nowadays, life without the internet means there is no life actually. But what will you do when you do not have any access to the internet? Okay, most of us will sleep, right? Or maybe read a books. But which is not our favorite option nowadays, as we love reading through our phone, which needs internet to surf into. Okay, so means that internet is everything. But do you know the history behind it? Okay, the internet. Actually, it started with a group of computers, 4 nodes to be precise, okay, that connect together to perform some experiment which involved Department of Defense US. Okay, the agency, which is under the DoD, Advanced Research Project Agency, ARPA, was interested in finding a way to connect computers so that the researchers they funded could share their findings, thereby reducing the cost and eliminating the duplications of effort, as mainframe computers in research organizations were standalones. And those computers from different manufacturers were unable to communicate with one another. So, in 1967, at an Association for Computing Machinery or ACM meeting, the ARPA presented its idea for ARPANET, a small network of connected computers, which the idea was that each host of computer, not necessarily from the same manufacturer, will be attached to a specialized computer called an interface message processor or IMP. So the IMPs in turn would be connected to one another so that the IMP will be able to communicate with the other IMP as well as with its own attached host. Therefore, in 1969, the Internet has become reality to 4 nodes, which located at the University of California at Los Angeles, the University of California at Santa Barbara, Stanford Research Institute, and the University of Utah, were connected via the IMPs to form a network. And then in 1972, Vint Cerf and Bob Kahn, both of whom were part of the core ARPANET group, collaborated on what they called the Interneting Project 1. Cerf and Kahn then marked 1973 paper outlined the protocol to achieve end-to-end delivery of packets. So this paper on transmission control protocol included concepts such as encapsulation, the datagram, and the functions of a gateway. Shortly thereafter, authorized made a decision to split the TCP into 2 protocols. One is the transmission control protocol itself, and another one is the Internet Working Protocol or IP. So IP will handle datagram routing, while TCP will be responsible for higher level functions such as segmentation, assembly, and error detection. So the Internet Working Protocol became known as TCP/IP. Okay, Internet today has come a long way since the 1960s. Okay, the Internet today is not a simple hierarchical structure. It is made of many wide and local area networks joined by connecting devices and switching stations. Today, most end users who want internet connection use the services of internet service providers. There are international service provider, national service provider, regional service providers, and local service provider. The internet today is run by private companies, not the government. Okay, first we look at the international service provider. International Internet Service Provider. At the top of the hierarchy are the international service provider that connects nations together. Like currently one of the top provider is China Telecom. Okay, and then we have national internet service providers. The national internet service providers are backbone networks created and maintained by specialized companies. There are many national ISP, operating in North America, but in Malaysia itself, we have Unify, we have Celcom, U-Mobile, we have DG, and etc. To provide connectivity between the end users, these backbone networks are connected by complex switching stations, which normally run by a third party, called Network Access Point or an AP. Okay, some national ISP networks are also connected to one another by private switching station called peering points. Okay, so this normally operate at a high data rate, which up to more than 600 megabit per second. Okay, next we have regional internet service provider. Or regional ISP are smaller ISP that are connected to one or more national ISP. They are at the third level of hierarchy with a smaller data rate. For example, Celcom. Okay, have you come across a banner or billboard that said this is Celcom territory? It means that at that particular area, Celcom have become the main provider. Okay, means that regional, the place. Okay, and then lastly, we have a local internet service provider. Local internet service providers provide direct service to the end user. The local ISP can be connected to regional or directly to national ISP. Most end users are connected to the local ISP. Note that in this sense, a local ISP can be company that just provide internet services. a corporation with a network that supplies services to its own employees, for example, your ITM, or a non-profit organization such as a college or university, okay, that runs its own network. Okay, each of these local ISP can be connected to a regional or national service provider. Okay, now we can define two widely used terms, okay, protocols and standard. Okay, first we define the protocol, which is synonymous with the rule, and then we discuss standard, which are agreed upon rules. Okay, first, in computer networks, communication occur between entities in different systems. Okay, an entity is an thing capable of sending or receiving information. However, two entities cannot simply send bit stream to each other and expect to be understood. Okay, for communication to occur, the entities must agree on a protocol. A protocol is a set of rules that govern the data communications. A protocol defines what is communicated, how it is communicated, and when it is communicated. The key elements of a protocol are syntax, semantics, and timing. Okay, let's look at syntax first. Okay, the term syntax refers to the structure or format of the data, meaning the order in which they are presented. For example, a simple protocol might expect the first 8 bit of data to be the address of the sender, the second 8 bits to be the address of the receiver, and the rest of the stream to be the message itself. Okay, and then we look at the semantics. The word semantics refers to the meaning of each section of bit, how is particular pattern to be interpreted, and what action is to be taken on that interpretation. For example, does an address identify the route to be taken or the final destination of the message? Okay, and then we look at the timing. The term timing refers to two characteristics: when data should be sent and how fast they can be sent. Okay, for example, if a sender produces data at 100 megabit per second but the receiver can process data at only 1 megabit per second, the transmission will be overload and the receiver overload the receiver and some data will be lost. Okay, now looks at the standards. Standards are essential in creating and maintaining an open and competitive market for equipment manufacturers and in guaranteeing national and international interoperability of data and telecommunications technology and processes. Okay, so the standard provide guidelines to the manufacturers, to vendors, to the government agencies and other service providers to ensure the kind of interconnectivity necessary in today's marketplace and in international communications. Okay, data communication standard falls into two categories. We have de facto, which means by facts, or we have by conventions, and then we have de jure, okay, meaning by law or by regulations. Okay, let's look at the de facto. De facto, standard that have not been approved by organized body but have been adopted as standard through widespread use are de facto standard. Okay, de facto standards are often established originally by manufacturers who seek to define the functionality of a new product or technology. Okay, so example of de facto standards are the QWERTY keyboard layout, which is the standard pattern in countries that use a Latin-based alphabet, and then we have de jure, okay, those standards that have been legislated by an official recognized body are the de jure standards. Okay, for example, we have is the ASCII character set. Standards are developed through the corporations of standard creation committees, and then we have forums and government regulatory agencies. Okay, on the slides is example of some committee that involved in creating the standards. But then we have forums which work with the universities and users to test, to evaluate and standardize the new technologies. By concentrating their efforts on particular technology, the forums are able to speed acceptance and use of those technologies in telecommunications community. Okay, so the forum will be then present their conclusions to the standard bodies, for example ISO or maybe the IEEE. And then we have the regulatory agencies. All communication technology is subject to regulations by government agencies such as Federal Communication Commissions in the United States, and in Malaysia we call as MCMC, Malaysia Communications and Multimedia Committee. Is it? Okay, I think so. Okay, so this committee, this agency, is to protect the public interest by regulating the radio, the televisions, and wire cable communication. For example, like our MCMC will state that which website that you can go, can surf, like there are certain boundaries to what we can look on, okay, search on. Okay, and then the MCMC also have the authority over the interstate and the international commerce as it relates to the communication. An internet standard is a thoroughly tested specification that is useful to and adhered to by those who work with the internet. It is a formalized regulation that must be followed. There is a strict procedure by which a specification attains internet standard status. A specification begins as an internet draft. So what is internet draft? Internet draft is a working document, or we call as means that it's still a work in progress, with no official status and a 6-month lifetime. Upon the recommendation from the Internet authorities, a draft may be published as a request for comment or RFC. So each RFC is edited, assigned a number, okay, and made available to all interested parties. So RFC go through maturity levels and are categorized according to their requirement levels. Okay, please do some exercise that I already put inside the slides, okay, and then we will be discussing about this in our class, okay. That's all, guys. Thank you.